Okay, here we go. Day 2, section 9.1. We got these two learning targets to finish up, okay? I can find the sum of a series, and then we're going to use something called summation notation to write sums. This is also referred to as sigma notation as well, because of the Greek letter sigma. Let me show you. Okay, so here's where we left off the other day. Here's the definition of summation notation. Okay, here's the Greek letter for capital S called sigma. It's kind of fun to draw. You just kind of, this is kind of how I draw it. Just kind of do this. Kind of looks like an E, capital E, if you will. All right, so that's sigma. We use that for sum of series, hence the word or the letter S. Okay, so here's how we read this. Our a sub n formula will be right here. Here they put a sub I. It doesn't matter what the letter is, but your formula will be here, and this tells you where you start and what term you end with. Okay, so right here it's saying 1 will be the first term. So just like yesterday, if I'm plugging in the first term for my sequence, 1 goes in. Okay, and then we go up to the last term. Here, I'll show you right here. Once you get used to it, it looks confusing and intimidating, but it really isn't that bad. So let's look at 13. Find the sum. Okay, so this is my a sub n formula right here. If you even want to write it like that, it's fine, or a sub I. So a sub I is I squared plus 1. Okay, and then this is my lower limit. This says let I equal 1, and then go up all the way to an I value of 5. So just like yesterday, we just got to start expanding the sequence. That's all. So I plug in 1. I can put some steps here if you want. Step 1, find the terms. So I plug in 1, I square it, I add 1, I get 2. Continue this process. Throw in 2. 2 squared plus 1, 5. Continue, continue. Okay, pause if you need to. I'm going to keep going. So here's my 5 terms from 1 to 5, and now it says to find the sum. So simply put, I just need to add these numbers together. Some textbooks call this expand the sum. So here I am expanding it. Answer 60. Okay. Remember, series, think about that in sports, right? We have the World Series. What does that mean? It's the team who has the highest number of wins in a series of games. Okay, so series means sum or sum of wins. All right, so I think that's enough for you to try 14. I'm going to modify this a little bit. I don't think we need to go all the way to 9. So why don't you cross out 9 and put 6. So remember how you read this. Here's your formula. You're going to start at term 3 this time. All right, doesn't always have to be 1. And this time it's 3. So to begin this, I guess I'll get this started for you. So to begin this, here's the third term. Okay, 3 goes in here and here. Use your arithmetic skills to figure it out, right? This is 4 squared, 16. This is 2. 16 times the 2 is 32. So there's my third term. Okay, once you pause and you try to go find a sub 4, a sub 5, and a sub 6, and get the sum. All right, here you are. Here's the other terms. A4, check to see if you got 75. A5, and then here's A6. Okay, add those 4 numbers together, and you get the sum of the sequence, or called series, 496. All right, I think that's enough for now. I think we can skip 15. You know how to do it now, though, right? We'd start at 2 and go up to 4, plugging in those 3 inputs, and then evaluate the function. Okay, let's move on. All right, so the last page, we're going to be working on this, kind of going backwards. Now they're going to give us the sums, expand it out, and now we're going to write it in sigma notation. So our final answer is going to look like these. Okay? All right, so I recommend you write down the success criteria up top. Okay, until you get used to this. Step 1 reads, find the a sub n formula, or I just put function for short. Find the a sub n function. Step 2, we want to determine the upper and lower limits. Okay, on the bottom of that sigma and the top of the sigma. Okay, and then 3, express the sum with sigma notation. Let's look at 16. Okay, so to find the a sub n function, that was just like some of the problems we did yesterday. I highly recommend you put the n values underneath it. Why don't you try it right here? Write in an n value of 1 under that a sub n formula, because this is already the formula expanded out. Okay, these are the a sub n values. So I've got 1, 2, and 3, and then it says dot, 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 and then this is the ending term. That's the end of the sequence. Okay, so how can I get a formula for this? Well, take a look at the numerator. It's always 5. Okay, so a sub n equals 5 up top. And then what about the bottom? Well, they made this pretty easy to see. Look, they put the n values in parentheses. So just 4 times n. Okay, and then it ends at 11. So there's the formula. All right, so this is the part that goes right here. This is your formula. Throw it in right here. Now we got to figure out the upper and lower limits. So what term would make sense to start here to get that? Well, it's got to be 1, right? Because I plug in 1, I get 5/4, which is right here. Okay, what would be the ending term? Well, it ends at 11, so it makes sense to put 11 as the upper limit. And that's the answer. Like I said, the end result is an expression in summation notation or sigma notation. Okay? All right, you can maybe you already saw a little bit of 17, but I want to see if you can figure out 17. Put the n values underneath. See if you can figure out the formula and see if you can figure out the upper and lower bound. Okay, also try 18. 18 is a little bit tougher, and I'm not even going to worry about 19 at this point. Okay, so try 17 and 18. Pause, give yourself 3 minutes, and then check in for feedback. All right, so here's your formula. Look, just focus on one at a time. Don't worry about the denominator. Look at the numerator. The numerator is always n. Okay, so that's what we're going to put. Now focus on the denominator. What do you notice? They're taking n and they're squaring it, adding 4 to it every time. Okay, so there's my a sub n formula. So throw it in right here. And then what was used first for the n value? It was 1. It usually is 1 for these problems, unless it gets pretty tricky like 19. And then looks like it's ending at 7. Okay, that's it. And that's how this reads, right? Find the sum of the sequence from 1 to 7. And there is the sum expanded. All right, here's 18. Remember, when these signs alternate, the best way to do this, and there's other options, as we saw this happen yesterday on problem 10. If it's alternating, you just do -1 to the n power. It happened again with 12. All right, even on page 1 and 2, it happened somewhere. So for 18, that's a good way to start. Put in the -1 to the n power. And then you just got to play with numbers, do some investigating. These are all powers of 2. 2 to the 5th, 2 to the 4th, 2 to the 3rd. That works. Okay, always check to see if your rule works. So if I plugged in, for example, 3, would it work? 2 to the 3rd times -1 to the 3rd. That gives me 8. That gives me -1. So I get -8. Perfect. Okay, the reason why they're doing plus minus is because, right, it's supposed to be a sum or sequence, so they're adding these numbers instead of commas. All right, now another way you could do this, you could put the -1 right in there. -2 to the n power would work. This would alternate signs, but just be careful. You can't do this, though. Okay, this would be 2 to the n, and then make it negative every time, and then we don't want that. Okay, so one of these two would work. Here's the final answer. It goes from 1 to 7. How do we know? Because 2 to the 7th is 128, and then we need it to be negative. Okay, 19 gets pretty tricky. If you tried it, there's the answer. If you didn't, I'm not going to worry about that one right now, okay? Okay, that's it for section 9.1. We'll have some follow-up next week, some review on this, and then we're going to add more problems about factorial notation. But that's it for today.